Welcome, everyone. Thank you for joining us online. We'll talk about accelerating Spring apps to cloud at scale, particularly on Kubernetes. And most importantly, you do not have to learn or manage Kubernetes. I'm Asir, on point for everything developers need to build, migrate, and scale Java applications on Azure. I started Java in 1995 with JDK1, and I have been working with Java ever since. Now, Spring has the largest mindshare among Java developers. These numbers and findings are from the most recent State of Spring report. Spring is a large family of modules. There are many modules. If you just take Spring Boot alone, it enjoys millions of downloads per month and growing rapidly, particularly new project starts. Spring and Spring Boot frameworks dominate today when it comes to building microservices. These numbers are from a Java EE community report. You can see how the Spring Boot line goes all the way to the right. Now, Microsoft and Pivotal, we have been working together for the last 5 years. Together, we have seen tremendous adoption of Spring and Pivotal platform on Azure. And our teams have been working on making that a great experience for customers, our developers. Now, as Pivotal became part of VMware, the partnership continues. When Azure and Spring come together, from VMware point of view, within this relationship, there's been a lot of activity on Spring on Azure integrations. Making Spring easier to run on Azure is tremendously important to the Spring ecosystem. It expands the reach of the community and the value to Spring users, Spring developers. From Microsoft point of view, we are seeing a lot of growth in the Java and Azure workloads. Over 95% of Fortune 500 are using Azure, and a significant number use Java, and a significant number use Spring. Spring is extremely important to Azure. We have invested in engineering along with the Spring engineering team in VMware on Spring on Azure integrations. These integrations make it easy to connect and interact with Azure data services. Could be SQL, MySQL, or Cosmos DB. Make it easy to interact with messaging service, whether you're using Kafka or JMS, Azure Service Bus, Event Hubs, or cache, Redis cache, or storage, Azure Storage, and Azure Active Directory, Azure Active Directory B2C, and so on. Right? Now, Java developers can use Spring Boot to build anything and get it up and running as quickly as possible. They can use Spring Cloud to coordinate anything between microservices. Spring Cloud brings the distributed style machinery patterns to Spring Boot apps. Now, when you lay them all out, let's look at a typical layout of Spring components for deploying Spring-based microservices. The center represents business apps or microservices interacting with the data, messaging, cache, and directories on your right. Now, business app consumers on your left are interacting with business apps in the center. The Spring Cloud middleware components are all laid around the business applications. Now, regardless of where you are deploying virtual machines or containers or Kubernetes, on-premise or cloud, whether it's Azure Cloud, Amazon Cloud, or Google Cloud, customers, developers are on point for building a dynamically scaling infrastructure to deploy all of these. That's a high effort. Many of our customers, developers, are trying to build these on containers and virtual machines. And once they have an infrastructure, say it is Kubernetes or virtual machines, they have to build app lifecycle on top of their infrastructure, such as create, deploy, stop, start, restart, blue-green, log stream, update, etc. It's difficult. It's painful. It's painful to wire them all up for troubleshooting and keeping an eye on production. Now, everyone must figure out how to solve for these things. And yet, they deliver directly no value to their business, but the center delivers a lot of value. If you're a bank, number of users, number of transactions. If you're logistics, number of packages being scanned, right? These are the direct measures that come from directly from your center, but all the other things, they don't directly add value. So this is where one of the most important things technology leaders can do is remove the impediments and friction for our customers, developers. So we started to ask the question, what if we could remove these impediments for even more developers? And of course, we wanted to work with Pivotal VMware on building this experience. And that is how Azure Spring Cloud was born. You can see how the product came together. Microsoft logo, Azure, plus Spring logo, they came together as Azure Spring Cloud. Now, Azure Spring Cloud is a fully managed service for Spring Boot apps that lets you focus on building and running the apps that run your business without the hassle of managing infrastructure. Simply deploy your jars or code, and Azure Spring Cloud will automatically wire your apps with the Spring Service runtime. Once deployed, you can easily monitor application performance, fix errors, and rapidly improve applications. It's integrated into Azure's ecosystem, and it is enterprise ready. At Spring One, a few weeks ago, Microsoft and VMware announced the general availability of the service. The service is jointly developed, operated, and supported by Microsoft and VMware. So our customers can get the best-in-class support from Azure and VMware experts. If you already have Spring Boot apps, zero code changes. You have to change coordinates for interacting with data, cache, messaging, and directory services in cloud. For application performance monitoring, it supports out-of-the-box monitoring and tracing, not only using Azure Monitor and Application Insights, but also popular application performance monitoring tools such as New Relic, App Dynamics, and Dynatrace. It's a fully managed service, and it also includes VMware's build service that takes care of jar or source to containers. The service is built on Kubernetes, and all the underlying details and the management is taken by Microsoft and VMware. So you do not have to learn or manage Kubernetes. Let's look at a little more details here. The big rectangle is Azure Spring Cloud. It's built on Kubernetes. Your apps is running in one of the two dedicated Kubernetes clusters for each service. Your apps can interact with any Azure service or external service. Logs, metrics, and alerts are available through Azure Monitor. You can secure your apps using Azure Active Directory and automate your apps using your favorite tools. Net, it's an easy way to get started. Focus on your business objectives, and everything else is taken care for you in cloud. Here, as you look at the Azure Spring Cloud, it has absorbed all the complexities with the infrastructure, Kubernetes, hosting microservice apps, app lifecycle, managing microservices, blue-green deployments, publishing logs and metrics. Now, all of these are supported by Microsoft and VMware. Let's look at a demo, right? Now it's a demo time. I have an app composed of Java microservices, and I want to run them on Azure. I'm not interested in doing a lot of ops work or Kubernetes. How can we do that? Right? Let's look at this popular Spring Pet Clinic microservices. Right? It's a pretty popular repo. You can see the number of stars and number of folks that are going on right here. If you look at this project, there are several microservices. Now, as I go down, there is an architecture here. If you look at this architecture, it's a distributed version of Pet Clinic, and it's modeled after line of business system. Imagine you're running a pet clinic and you have customers, you have doctors, the veterinarians, the pets, and you have to schedule and monitor, manage their schedule, right? So that you can smoothly run. So if you look at this, your personal line of business system users will be coming in through here, through the gateway. And here's the customers and all the pets are managed here. Your doctors, the veterinarians are managed right here. And then you can see the visits, they're all managed here. And there's data. The data are self-contained. And you can see how they are going one microservice at a time, and they have a Spring Boot admin server as well. And there's a bit of machinery around here. You can see how API gateway is an entry point, and there are about 3 microservices and 1 Spring Boot admin server, and everything else is nothing but a Spring Cloud middleware at this point. I already took the liberty of deploying these apps to Azure Spring Cloud. Let's take a look, right? So here is an instance of Azure Spring Cloud. You can see that the Azure Spring Cloud is running in West US 2, and it's actually ready to go. Let's look at the apps itself. If I go here, you can see the entry point app gateway. And you can see the other 4 services: customer service, vet service, as well as visit service. They're all up and running at scale. Now let's open this application and see how it comes up. So I'm going to open a new window here. So here I'm going to type Akka MS Pet Clinic. And you can see the app is coming up, right? So when you look at this app, right, I can go into managing my customers, where I would see all my customers are here, right? They're all right here. And I can actually go ahead and add a new customer as well, right? I can manage my doctors, the veterinarians, right? Back to all my customers here. If I look at one of these customers, they have many pets. So let's look at John Coleman. So John Coleman has 2 pets. One is Max, the other one is Samantha. And I can go ahead and add a visit or edit, or I can go ahead and add a new pet as well. This way I can run my business, the pet clinic, right? Now, the app aside, let's look at the details of how they are actually deployed. So let me kill this particular window, right? Now, how did these 5 services wire up, and how do they talk to each other? Well, I didn't have to do anything really. When you deploy apps to Azure Spring Cloud, the service makes them discoverable using a managed Spring Cloud service registry. So what you see here is nothing but a manifestation of the Spring Cloud service registry in Azure portal. Now, what if you want to change app configuration without redeploying all these microservices? How can you do that? So this is where we have the config, right? So config is the next blade here, where what I have done is I have used a Git repo to actually configure. So this is right on GitHub now, right? Now this config server is nothing but a Spring Cloud config server. It's a managed instance. You can see the Git repo wired in for config. You just push a change to your config repo, nothing but a git push, right? And the apps will update automatically. Now, does this mean that you have 2 more components to worry about, a config server and a service registry? Not at all. They're all fully managed. You don't have to worry about it. Now, let's say I go back to the apps itself. I am concerned that we do not have enough instance of the customer service, right? So let me scale that up, right? So I go here into my customer service. My customer service is right here. It's actually up and running, and you can see the workload that is coming in pretty, pretty much right here. So I can go into my scale out. Scale out is right here. So when I go into scale out, I can scale any of these apps. So I'm going to choose customer service, right? And I click on it. I have an option to manually scale or auto scale, right? Auto scale means you're going to specify the upper limit and the lower limit with some metrics or schedule, and then it'll automatically scale accordingly. But let's try the manual scale. I'm going to increase it to 10 here, right? Now, all I have to do is after, well, by the way, I can increase all the way to 500, 265, 200, 300. I can go up to 500, as many as I want. But let me limit to 10 for now, right? So as I say, it will now start scaling out for me. So soon there'll be more instances up and running, right? Now, let's come back to the scale numbers later. I like that so many things are managed for developers. But what if there's a problem with my app? How can I see what is going on right here? Let me go to the next screen here, where you can see that that there is diagnostic settings for Azure Spring Cloud. Now, diagnostic setting is fundamental across all the Azure resources. For any Azure resource, you just go there and set up and say, send my logs and metrics to Azure Monitor. From there, you can take it to any log aggregator. So here, what I have done is I have set up in a way the logs and metrics are going to log analytics. You can see all the logs, all the metrics are going into log analytics. Now you can also send it to anywhere you like. I have another setting here where I'm actually sending them to Elastic. Once you send them to log analytics, then all you have to do is run a bunch of queries to get your logs, right? So let's take a look at a few examples here. So here I am asking for, I'm using a query language called Custo, which runs against log analytics. So using the Custo query language is just like SQL. I'm saying, get me all my API gateway logs. If I run it, all my logs will come right here. And then I can step through and see what's going on. So let's take a look at this log, right? And you can see that this one looks okay, right? It was trying to fetch something from the config server. So that one looks okay. Now I can also ask for my logs for other apps. So here I'm asking for the customer service apps. So when I run it, you will see all my customer service apps are now coming through. You can see all the logs, they're all here, right? I can also ask for all my errors, right? So give me all my errors and exceptions that are happening across, right? So if I run it, you would see all my errors and exceptions will be coming through right here. Now you can see that there is an exception going on right here. See, it's a concurrent timeout exception, right? So one thing I did today is there are 6 apps. I only deployed 5 of them intentionally. And the 5 are trying to reach the 6th app. So whenever they are trying to reach, they will be throwing some kind of exception. So I can show you this exception, right? Now, in addition to getting them as a table, I can also get them in pie charts, right? So here, in here, when I run this, you would see that it'll bring back all the exceptions and errors that happened in the last 24 hours and then start drawing them as a pie chart. Now, you see plenty of exceptions going on. And the reason is, again, I did not deploy one of the apps. I only deployed 5 instead of 6. And they're all trying to talk to the 6th one. Right? So you can come up with charts that you can use to illustrate what's going on here as well. Now, what if something happens to the config server, right? So here I can say, give me all the errors and warnings that happen inside the config server. So when I run it, a few entries come. So let's take a look at this. It was not able to get something from GitHub. Probably the internet went down, probably GitHub was not available, so it records that it was not able to get it at that time, right? I can also get all my logs for config server, right? Anything and everything that happens here. So this query will get me all my logs for config server. So when I run it, you're going to see all of them show up here, and then you can have an understanding of what's going on here. So here is here it is it's a log that it was trying to get the application.yaml from GitHub, right? So you understand what that is right here. Now, in addition to this, since this is an overall fundamental for Azure, in the case of Pet Clinic, we have MySQL up and running. I'm also sending all my logs and metric from MySQL to Azure Monitor and receiving them in log analytics. Now, once I receive, I can write a bunch of queries against MySQL logs as well. So here I'm asking for all the SQL queries that have been run on the MySQL database. When I run it, you're going to get all of them. And from there, when you are troubleshooting, you can look at which one went wrong, right? So here, let me open up this entry. And here you see the SQL queries right here. Select PT P0 ID. That's the query, right? So you can see all the queries here. Now you can magically run all kinds of queries to get the commands so that you can troubleshoot, you can plan capacities, and keep an eye on production as well. If you're a developer like me, you probably don't want to go through all these screens. Hey, can I get my log stream on my dev machine? Certainly, right there. So we would go into a command line here, and you would see Azure Spring Cloud app, ask for logs, and you want to tail it and tell me what is the name of the service. So in this case, it's customer service, right? So I'm asking for it. At this point, it will start giving me the log. Oh, it says it found 10 instances. 1, 2, 3, 5, 6, 7, 8, 9, 10. Oh yeah. So do you remember we were actually trying to actually scale it out, right? So there are now 10 instances. So I'm going to choose one of the service right here and say, at this point, I would say, hey, I actually want it for this particular instance, right? So when I say it, it will start bringing me all the logs to my machine. There you go. So it's now tailing, right? All the logs are here. And when something goes wrong, you will see the exceptions right here so that you can go back and double check what went wrong, right? And troubleshoot as well. So let me kill this at this point. So killed it. I'll go back to right here, right? So that's nice. If something is broken, I can go and troubleshoot. Now, what if I want to be alerted before things break apart, right? So this is where in Azure, we have the concept of alerts as a fundamental across all the Azure services. So I'm going to go into the metrics blade. So under metrics blade, I can choose what metrics I want. In this case, I'm actually choosing all the requests that arrive into Azure Spring Cloud. So you can see all of them are here, right? Now, based on this, I can start creating a new alert here. So for example, I can say, if the number of requests arrived is greater than 20K, please act on this action group. So at that point, the action group could be sending a text message, calling somebody, leaving a voice message, or opening a Jira ticket, or integrating with X Matters. Any of those are possible, right? Okay, so I used microservices so I can scale out these components individually. How do I know which microservices calls are slow so that I can do some tuning for performance, right? So this is where you can use Azure Spring Cloud's distributed tracing feature to view average request times, average number of calls, or the total number of calls through the distributed tracing. So distributed tracing is realized through integration with application insights. So I'm going to go here. When I look at the distributed tracing, you can see it's a complex diagram because it shows the complete map here, right? So if I zoom in a bit, as I zoom in, you would see that the API gateway is here. It received about 4 million calls in the last 4 hours. The distributed tracing has a sampling rate of 70%. So it only captures 7 out of 10 calls for representing this diagram, right? Now, in the last 4 hours, we received about 5.6 million calls, right? Now, the calls that are coming in then get distributed to customer service, right? A sizable amount go to customer service, another sizable chunk go to visit service, another sizable gets distributed into web service as well. Now, all of them depend on database, and you can see how the calls are going directly into the database itself. I'm searching for the database, which is somewhere right here. Right. So all the calls are going into the database. Here is the database. You can see the pet cleaning database is right here, and all the calls are coming in. Now you see some things are red and some things are green here. The reason you see the red here again is because I did not deploy the 6th application. I only deployed 5 of them. So they're all trying to talk to the 6th and it's bleeding apart, right? Now, if I go into this application gateway, the sizable number of calls are going into customer service, and I want to look at and see what's going on. So all I have to do is choose this. Once I choose this, in addition to these incredible views, I now get some actionable insights right here. As you can see, there are a number of calls going out, and some are pretty fast and some are slow. And it's giving me the option to investigate performance. So if I click on it, the context sensitive, the operations information will come into view right there. As you can see, some of them are pretty fast, right? They are 8 milliseconds, and some are slow, 783 milliseconds. So I can choose it and then say, I want to drill into this, right? So when I choose this, what happened is, and it happened somewhere here across time, right here around 12:28 today. So I can drill right into it. So when I drill in, it brings me a list of things to drill. So I can choose one of them. Now the entire call stack will come into view, right? You can see the call stack. At this point, there are many calls going on here. Some are pretty slow. So let me select one that is slow right here. This one is slow. This one is fast. This one is slow as well. So this way I can look at what is going on and troubleshoot at this time, right? Now, as we were looking at the overall view, if you have hundreds of applications running, that can be confusing, that image, right? So what I would do is I would typically go into that application distributed map and choose one of them and just focus on it, right? So when I focus on it, in this case, I'm only focusing on API gateway. And you can see how the only view that comes into focus is its dependencies, right? In this case, in the last 24 hours, about 24 million calls came in, right? Now, the 24 million calls is again a 70% sampling rate. So the full set is about 33 million calls came in the last 24 hours. And I can zoom in and I can go a little big and you can see how the calls get distributed back across all the other, how it gets routed to all the other calls as well, right? Now, in addition to looking at the overall distributed tracing and focusing on one of the app, we can also go into the details of the time taken for each of these operations, its dependencies. So let me take you there. So here, in this case, it's the performance, right? It's the performance of all the operations that came in, right? So here some are pretty fast, some are pretty slow, and you can determine why that is slow, right? And you can also look at the dependencies, right? In this case, there are lots of dependencies, and you can see SQL is the top one. In the last 4 hours, there were about 11.5 million calls, and they only took about, on the average, about 11 milliseconds, right? Now you can choose any of these and start drilling deep into it as well, right? Now, in addition to that, I can also open up my failures, right? So if I open up my failures, all my failures will start showing up right here in this window. It's currently loading up, and you would see that all my failures will show up, and I can say I want to see all my exceptions, right? And you can see a lot of exceptions are going on here. And the reason is, again, because I did not deploy the 6th application. Now you can drill into that exception, right? What exception? I'll pick one of them. There are many here. I pick the top one and suggest me something to drill on it. So I'm going to drill on one of them. So here is my drilled one. And you can see there's an exception going on. As a developer, I want to see what my call stack is, and I can pick up, and here's my call stack. And you can see the full call stack. That gives you enough insights into what is actually going on right here at this time. Now, in addition to the end-to-end transaction details, I can also look at my live metrics coming in. Now, this is live metrics from all the apps deployed to Azure Spring Cloud. The latency here is less than 1 second. So you know what is going on right now as the calls are coming in. So you can see the request rate is here. The request duration is here. Some of the exceptions are here, and the consumed memory is here. Now, you can also get details on app instance level, right? And you see customer service, there are about 10 instances here. Now, you can see how much memory it is taking for each of these instances, how many requests per second it is actually processing right now, how much memory is committed, right? All these details are here. So this will give you enough information to understand what is going on. Now, in addition to this, we also have this diagnostics as a service so that you can figure out by yourself, right? So when I choose here, it gives me plenty of options right here. You see? Now, within these options, what I did is I actually chose one of them. So in this case, it's the CPU usage, right? If I go into the visit service, that's the CPU usage. If I go into customer service, that is the CPU usage. There are many more, right? All of those are documented right here in docs on Microsoft.com, where it explains all the variables available, metric names, variables available to you for you to monitor and diagnose the issues by yourself, right? Now, in addition to this, out of the box, other application performance monitoring tools are supported. Let me show you one. In this case, I wired up New Relic. It's the same 5 apps, right? Admin server, web service, customer service, they're all here. I just opened it up in the New Relic dashboard, right? And you can see the throughput that is currently happening. I can drill into one of this, right? So let's go into the customer service, right? This is a live shot through New Relic. Right now, in the last 6 hours, this is the transaction time, right? It took sometimes about 3 milliseconds, sometimes about 8 milliseconds, sometimes about 42 milliseconds. You can sometimes about 400 milliseconds, depending on which call you're looking at. And you can also get your app score. Your throughput is here, about 12.7 calls on the average per minute, right? This is just the customer service alone, right? There are many apps up and running, right? And you can look at any app here. You can also get your error rate and all the transactions that are happening and the 10 instances that are currently running. You can look at the JVM information as well, right? So if you're familiar with New Relic, you can continue to do that. Right? Now, if you are a Spring Boot developer, you are familiar with actuators. So you can turn on your actuators just like the way you used to. In this case, I've turned on all the actuators, so you can see all of them are exposed. And I can also get my environment variables, right? So all my environment information is right here. This way, when I'm troubleshooting, I can check what is currently in effect. For example, the log level pattern is right here. And I can also look at my config props, right? All of them are exposed through the actuator portal, actuator endpoints, right? Now, everything I showed you here is actually in a GitHub or GitHub repo. So here you see, this is the same. It's a fork of it. What we have done is we have added all the instructions to run it, right? It's the same thing, that plus instruction. Now, to deploy it, there are two key steps, right? So let me show you the key step. The first key step definitely is to create this Azure Spring Cloud service. So this command creates it. So that's the first one. The second one is to deploy. So you can see how I have deployed the API gateway, admin server, customer service, web service. It's nothing but a command that just deploys the jars into Azure Spring Cloud. Now, if you look at this command here, where we are deploying to customer service, we are passing a jar, and we are sharing some secrets for the app to boot up, so it can connect to MySQL database right there. Let's look at the details of this particular application here, right? So this is the customer service. You can see the calls that are coming in, right? Now, let's look at its configuration, right? Since I was passing the environment variables, they're all right here, right? Now, anybody who has access to your service, maybe your developer or your apps team, ops team, or your app team, or your SRE, can come here and just reveal these secrets. Once they reveal, the secret will be seen, right? Now, if you want to manage these secrets, and you want to safely load it in a way that nobody can see it, only your chief security officer who's typing in these secrets can see it, or anybody that he wants to grant access, and only for the app, when it boots up, it's able to get the secret. There is a way to do that. That's the zero trust model, right? So what I would do is I have an alternate deployment here of Spring Cloud microservices here, which is the Pet Clinic microservices 2. In this, I have the config server. Now, what I have done here is I've enabled a machine identity called as the system assigned machine identity. You can see this is a machine identity. And then I have loaded all my secrets to Azure Key Vault. You see all the secrets are here: database name, login name, password. Once I load them all I have to do is I have to go into the access policies and grant only access to the app. So in this case, I'm granting access to the 5 apps that are up and running in Azure Spring Cloud, right? And once I do this, when I deploy, all I have to do is just say deploy my jar, and I'm not passing any secrets at all, right? That way, nobody can see it. So your chief security officer or whoever he wants to grant access, plus the app, it only safely loads them when it starts bootstrapping and starts up and running. This way, all your secrets are safeguarded. So that's the demo of Azure Spring Cloud. So here, what we did is we took a Java microservices or Spring Boot apps, and we deployed to Azure without worrying about infrastructure and scaling, without worrying about Kubernetes. I don't have to learn or manage them. I don't have to worry about the middleware, config, registry, tracing. All of them were taken care of for me. And monitoring, similarly, everything is taken care of, right? Now, once I deploy the apps, you can visualize them through the portal, right? You see a view right here. And then I can set up the diagnostics like you always do to send logs and metrics to Log Analytics or any aggregator of your choice. It could be Elastic or Splunk or something else, right? Once you have set it up, You can troubleshoot by inspecting logs and log analysis, just a matter of running queries. If you're using Elastic, using KQL, right? Or you can open the log stream, right? In this case, you can see how many exceptions are going on, and you can see that and then start reacting to it. You can also monitor, like particularly which app instance is misbehaving or slow, right? You can monitor the performance, you can zoom into it, right? That way you understand the interaction and which instance is misbehaving. But you can identify and then troubleshoot. You can monitor the performance through application insights. You can look at the dependencies and drill into it. You can also view your errors, right? Your exceptions, and then drill into the exception and get a copy of the exception and understand what's going on, right? You can also manage secrets, zero trust model. You saw on the left where you can see the secrets, and as I move to the right, safely loaded. You can also isolate all your apps and your runtime from the internet and then selectively expose them. In this case, the Azure Spring Cloud is placed on a virtual network in your corporate network with perimeter controls like application gateway, Azure firewall, and then connected to your on-prem, right? That way, when the inbound traffic is coming through, you can filter, you can eliminate all the malicious IPs and FQDNs, and then only allow the ones that are allowed to reach, and then only expose what you want to expose, right? And we also have the demo code. They're all in GitHub, so you can take it and try and run exactly the way I showed it to you, right? In summary, Azure Spring Cloud, when you deploy to Azure Spring Cloud, the service simplifies infrastructure management. It carries rich application lifecycle at the microservice level. Monitoring is a breeze. And there are plenty more features in Azure Spring Cloud. The most important thing, it is running on Kubernetes, and you do not have to learn or manage Kubernetes. Once the apps are up and running, apps can interact with Azure data, cache, messaging, and directory services using rich idiomatic Spring integrations. And to close, everyone online, thank you for joining us today. Everyone can build cloud-native solutions today and advance them to production. We love to hear how you are building impactful solutions using Azure Spring Cloud. You can get started today. Quick start is a good start. You can also use a self-paced workshop. We have migration guides for you. Let us know how you're building impactful solutions. Thank you again for joining us.